On October 3rd, 2025, China's Tianwen-1 satellite captured the closest images we have ever had of an object that came from another star. It was a remarkable technical achievement. But what it found does not follow any laws of physics that we know. The object is called 3I Atlas. It went through a phase of skimming past the sun and lost 13% of its mass. That equals 4 billion tons of material ejected into space. When a natural comet loses such an enormous amount of material, it leaves behind a trace. A large tail, bright and glowing, stretching millions of kilometers. But the images from Tianwen-1 show something completely different. Just a fuzzy sphere. No tail, no trace whatsoever of those 4 billion tons of material. Why? That is the first question. But it is not the only one. There are 10 documented anomalies. Each one is rare. All 10 at the same time. The probability is only 1 in 10,000. To understand what happened, we must go back to July 2025. At that time, interstellar object astronomy had become a real scientific field, no longer science fiction. In 2017, astronomers worldwide were shocked when they discovered Oumuamua, the first confirmed object from beyond our solar system. It came from outside our solar system, moving at 26.3 km/s, one of the most important discoveries of the 21st century. But strangely, it was announced with a cold silence. Governments did not attract attention. No international announcements. Just data quietly exchanged between scientific organizations. In 2019, Comet Borisov, the second interstellar object, was discovered. This time, the announcement was more widespread, but something was still strange. There was still silence from governments. There were still questions that were not fully answered. And then came 2025. On July 1st, observatories from Europe to America, from Japan to Australia, detected a new object. Its name, 3I Atlas, was given according to international convention. But this announcement was different. Usually, astronomers would rush to announce such news immediately. Press conferences, scientific papers, public debates. But with 3I Atlas, silence was the first thing noted. The major organizations, NASA, ESA, European Space Agency, SETI Institute, and China's National Space Administration, CNSA, all knew. Within 3 weeks, they exchanged data in silence. No public announcements, no media frenzy. Then October came. Tianwen-1, a Chinese spacecraft that had been orbiting Mars for over 4 years, was given a special mission. Instead of photographing the surface of Mars, it had to turn around. It had to catch an object smaller than Manhattan, darker than black plastic, moving faster than anything natural in our solar system. This object was 18 million kilometers away from Tianwen-1. The challenge was enormous. But on October 3rd, Tianwen-1 succeeded. It captured the images, not clear images, not high-resolution photos. Black and white, blurry photographs. But they revealed something no one expected. On November 5th, China's National Space Administration released these images. They called it an important technical achievement, a test for deep space missions in the future. But they did not highlight what made these images historic. These are the closest images we have ever had of an interstellar object. Closer than Hubble. Closer than James Webb. closer than any telescope on Earth could ever receive. These images will be the last evidence we ever have of 3I Atlas, because in a few weeks it will leave the solar system and return to interstellar space. Time is running out. The data we receive now, this data, is everything we will ever have. Now consider what scientists have discovered. Listen to the data. Every event I am about to tell you has mathematics behind it. Every number, every calculation, every observation. All are confirmed by independent scientific organizations. And all challenge what we know about comets. When 3I Atlas was first detected on July 1st, astronomers worldwide began calculating its orbit. It is a standard procedure. When you discover a new object, you calculate its path. You use Kepler's mathematics. You determine the orbital elements. You predict future positions. Within a few weeks, as calculations were completed, something became clear. The orbit of this interstellar object is not random. It does not follow what we would expect from a stray visitor from interstellar space. Instead, 3I Atlas lies nearly completely within the ecliptic plane, the same plane as all our planets. To understand why this is strange, imagine a picture. All planets, Earth, Mars, Jupiter, Mercury, Venus, all orbit the Sun in the same flat plane, like marbles rolling around the rim of a plate. This is a common image, but it captures the basic idea. They all lie near it. Why? Because they all formed from the same rotating disk of dust about 6 billion years ago. So it makes sense that they lie in the same plane. They are children of the same system. But 3I Atlas did not form here. It is not part of the original solar system. It came from interstellar space, a place with no preferred direction, no universal plane that all stars follow, no universal disk. Therefore, an interstellar object could come from any direction, from above, from below, from the side, from diagonally, from all possible directions. There are millions of possibilities. The probability that it would come from a direction lying nearly completely within the ecliptic plane is very low. But 3I Atlas chose an orbit only 5 degrees offset from the ecliptic plane. 5 degrees. From millions of possibilities, it chose one of the few. The probability of this coincidence is 0.2%, 1 in 500. This is just the beginning, just the first anomaly. In July and August 2025, as 3I Atlas approached closer to the Sun, many observatories worldwide noted something never before seen. 3I Atlas was ejecting a jet of gas, but not away from the Sun. Instead, it was ejecting toward the Sun, directly inward, the opposite of every natural law we understand. This never happens with a natural comet. Let me explain why. When a comet approaches the Sun, temperature rises. It does not just increase a little. It increases dramatically. Ice that has lain frozen for billions of years is suddenly heated intensely. Chemicals frozen in the core, water ice, methane gas, complex organic compounds, they vaporize. They become gas. This creates pressure. This pressure, combined with solar wind, pushes material outward, pushes it away from the Sun, never toward the Sun. Never. This is basic physics. Pressure from within, solar wind from without, both push material outward. But 3I Atlas did this. It ejected inward. toward the sun. Calculations from NASA's Jet Propulsion Laboratory, JPL, one of the world's leading scientific agencies, show that the acceleration from this jet is 3.7 pi 10 to 7 astronomical units per day squared, perpendicular to the sun's direction. This is not a random number. This is not a guess. This is a measured number. It is calculated from data. It means something. It means something if someone or something is controlling it. If there is a small engine, a small jet programmed to eject in a specific way, in a specific direction. Now we come to the most complex part, the part that makes scientists silent. During the time 3I Atlas skimmed past the sun closest, called perihelion, on October 30th, it lost 13% of its mass. This is not an estimate. This is not a guess. The Tianwen-1 spacecraft recorded these changes directly. NASA's JPL confirmed the calculation. Independent astronomers verified the data. This is a measured fact. 13% of a mass of 30 billion tons equals 4 billion tons of material. 4 billion tons. Imagine that number, the entire ejection in a few days. This is not a gentle ejection. This must be a spectacular event, like the largest volcano on Earth, like a natural disaster. Dust particles would be pushed by sunlight. Sunlight actually has pressure. Sunlight actually can push material. Gas molecules would be pulled by solar wind. All of them would create a giant tail, a tail stretching millions of kilometers. You could see it from Earth with a small telescope. But when astronomers photographed 3I Atlas, just 6 days after it passed perihelion, what did they see? On November 5th, the Virtual Telescope Project in Italy photographed it. On November 5th, the Naves Observatory in Spain also photographed it. Both recorded something different. A small sphere, a thin coma, no tail, no trace of 4 billion tons of material. For comparison, Comet Lemon, a natural, ordinary comet, was photographed just 2 days earlier by the same Naves Observatory. It has a clear tail, a well-defined tail, a tail spreading across the sky. It looks like what a comet should look like. 3I Atlas does not. 3I Atlas has no tail. Why? There are 9 other anomalies. Each one is documented by independent scientific organizations. Each one is confirmed. Abnormal brightness. 3I Atlas is too bright for its known size. If you calculate based on its size, 5.6 kilometers, and you assume it has the normal reflective properties of a comet, it should not be this bright, but it is. Why? Perhaps its surface reflects light better than normal. Perhaps it has a metal shell. Perhaps it is designed to reflect light. Different chemical spectrum. When astronomers analyze light from 3I Atlas, they look for expected chemical lines. They want to see lines of water ice, cyanogen, ordinary comet compounds. But 3I Atlas's spectrum does not match any comet in history. It is different. It is unique. It cannot be explained. Abnormal density. Based on size and mass, 3I Atlas is too dense. It is denser than a normal comet. It is nearly as dense as a metallic asteroid. Why? Comets are made of dust and ice. They should not be this dense. But 3I Atlas is. Strange rotation period. 3I Atlas rotates fast. Too fast to have a clear gravitational explanation. A comet should not rotate this fast unless it is designed to rotate, unless there is an internal engine spinning it, unless it is balanced in a specific way. 3 sudden brightness flares. Over several weeks, observatories recorded 3 times when 3I Atlas suddenly became brighter. Once, twice, 3 times. Like it is testing a system, testing if it can brighten, testing its lights, testing its sensors. Strange surface structure. From the Tianwen-1 images, the surface does not look like a comet. It is not rough, it is not irregular, it is too smooth, too geometric, too designed. Final acceleration burst. After passing perihelion, after 3I Atlas had passed its closest point to the sun, you would expect it to simply continue moving along its elliptical orbit. But it does not. It accelerates once more, as if a backup engine was activated, as if additional fuel was burned. Each of these anomalies, by itself, could be explained by a natural exception. Perhaps, maybe, but you must accept that each explanation is an exception. A rare comet could have an unusual surface structure. An object could rotate fast. A comet could have an unusual spectrum. An object could be shinier than normal. But all 10 at the same time in the same object? When you start stacking exceptions on top of each other, one exception for the first anomaly, another exception for the second anomaly, a third exception for the third anomaly, something happens. Probability decreases and decreases and decreases until it drops below 1%. So if not a natural comet, what is it? There are 3 possibilities. Each is built on logic, each is plausible. The first hypothesis is that 3I Atlas is a natural comet. Just a natural comet with all these anomalies. By coincidence, the universe is very large. There are billions of comets. Something could be true one time in 10,000. Something could be bad luck. A natural object with all these anomalies at once. This is the explanation supported by mainstream organizations. NASA says, we will continue researching. ESA says, we need more data before drawing final conclusions. SETI Institute says, we found no clear evidence of artificiality. They are not wrong. This is the right scientific method. To investigate, you must seek natural explanations first. You cannot jump to strange conclusions without considering the ordinary first. But here is the problem. When you need 10 independent exceptions to explain an object, you begin to ask, are there too many exceptions? The second hypothesis is that 3I Atlas is not natural. It is an automated device, a probe or satellite from an interstellar civilization. If you were an extraterrestrial civilization and wanted to send a probe to survey a new star, what would you do? You would design it to move in the plane, easy approach. You would give it engines to adjust its trajectory. You would give it small jets to adjust direction. You would give it the ability to accelerate when needed. You might not want it to leave a large trace, so instead of ejecting gas randomly, Your device would control the ejection. It would remove material deliberately on purpose. Perhaps the surface is designed to not reflect light too strongly, or structure to withstand extreme temperatures. If that is the case, then 3i Atlas could be a probe from somewhere, from some star hundreds of light years away, from a civilization we have never known about. The third hypothesis is we created it, a secret program from the 20th or 21st century, a device developed by the US, Soviet Union, or China, a tool launched into space decades ago, and now it has returned. If that is the case, why are governments silent? Why don't they say, it is ours, we control it? Why let the public worry? Or is it because they want to hide the truth that these technologies exist? To test these hypotheses, scientists use a binary test. If 3i Atlas is natural, then its trajectory will follow Kepler's equations. It will move along a perfect ellipse. No deviations, no unexpected changes. But if it is controlled, its trajectory will have small deviations. Engine adjustments, planned changes. So far, data shows deviations, but not clear enough to say for certain. Now let me pause. Consider what the mainstream says. Listen to them truly. Understand why they are so careful, why they refuse any hasty conclusion. Because what they say also makes sense, at least at first glance. NASA says the ejected material could be mainly gas, not dust. Gas is harder to see than dust. In the extremely rarefied conditions of space, gas can disperse immediately, leaving no clear trace. You simply cannot see it. That is a reasonable explanation. Actually, gas is much harder to see than dust. Dust reflects sunlight. Gas, if not ionized, is nearly invisible. It can disperse into interstellar space, leaving no clear trace. This is a scientifically sound argument. But here's the problem. ESA's R-Naves Observatory in Spain uses special technology to detect exactly those gas emission lines from celestial objects. They do not just take regular images, they use spectrography, a tool that analyzes the light emitted by chemical molecules. When they photographed Comet Lemon days before 3i Atlas, they clearly saw hydrogen emission, cyanogen emission, clear gas lines, no mistake possible. Why don't they see it in 3i Atlas? If 3i Atlas ejected 4 billion tons of material by NASA's calculations, then even if it were all gas, it would still produce a detectable gas emission, but it does not. ESA says, our viewing angle could be off. We could be looking at the tail edge on, unable to see it. That is another reasonable explanation. If you look at a comet's tail from its edge, instead of from behind or in front, it might look very thin. It might be nearly invisible. This is a simple geometric effect. It happens in reality with some comets. You look at it from one angle, it looks large and clear. You look from another angle, it nearly disappears. But here's the next problem. 3 independent observatories in Europe, R-Naves Observatory in Spain, in America, Virtual Telescope Project with American observation data, and in China, Tianwen-1, all photographed 3i Atlas, all from different viewing angles. Their coordinates are not the same. Their orbital positions are not the same, but all show something similar. No tail, no trace of ejected gas. The probability that 3 completely independent observatories, located in different places on Earth, all look at 3i Atlas from exactly the edge angle at the same time. That is very low. Too low to consider random. The mainstream argues Occam's razor. The simplest explanation is usually correct. A natural comet is simpler than an artificial object from space. We should accept the simpler explanation. That is a good argument. It is based on a valid scientific principle. Occam's razor says you should not multiply entities unnecessarily. The simpler explanation is usually truer than the complex one. But the problem is Occam's razor cuts both ways. To explain one anomaly as natural, you need one exception. Simple. To explain 10 anomalies as natural, you need 10 independent exceptions. Each must be a separate coincidence. It is complex. Very complex. You are stacking 10 hypotheses on top of each other. But to explain 10 anomalies as artificial, one automated device from space, you need only one explanation. It is a device designed to do these things. It is designed to have a coplanar trajectory. It is designed to eject jets in specific ways. It is designed to leave no large trace. Simple. One explanation. One purpose. One design. When you stack 10 exceptions on top of each other, 10 independent exceptions, each requiring separate hypothesis, you are no longer following Occam's razor. You are cutting against it. You are advocating complexity. You are seeking 10 different reasons for something to happen instead of just one. Occam's razor does not say the natural explanation is always correct. It says the simplest explanation usually is. When the natural explanation becomes too complex, too many exceptions, too many coincidences, too many things that do not fit, it ceases to be simple, and Occam's razor begins pointing the other direction. Finally, the mainstream says, no final conclusion until we have absolute proof. We will continue surveying, analyzing, contemplating. When we have enough data, we will know. That is a cautious, responsible, scientific statement. And it is true. Science must be careful. Science should not rush to big conclusions based on incomplete evidence. That is a fundamental principle. But here's the real problem. What is absolute proof? To have absolute proof, what would you need? Could you probe the object? Could you interrogate it? Could you send a spacecraft to meet it, integrate with it, analyze it from within? No. Because in January 2026, just a few weeks from now, 3I Atlas will leave the solar system. It will pass Mars's orbit, then Mercury's, then cross the boundary of our solar system. It will return to interstellar space. It will move with high velocity, receding from Earth, becoming dimmer, harder to observe, until it is completely beyond our reach. The chance to gather more evidence will disappear. The only opportunities to observe, analyze, explore will close. There will never be absolute proof. Only the data we have now. Only the images from Tianwen-1. Only the orbital calculations. Only ground observations. And only silence. Government silence has told us much, if we listen. The mainstream says, not enough evidence. But the mainstream is also peculiarly silent. They do not celebrate the discovery. They do not call for international cooperation. They do not publish detailed technical reports. They are silent. And this silence is an action. It is not doing nothing. It is a deliberate decision. It is a choice. But it does not end here. The data is telling us something larger, deeper, more complex is happening. What we thought was an isolated event is actually just a small piece of a much larger picture. A picture that governments have perhaps seen long ago, but never shared with us. Go back to 2017, a discovery that changed astronomy forever. A strange object named Oumuamua was first detected from beyond our solar system. It came from another star, moving at 26.3 kilometers. Remarkable was, it had an unexplained acceleration that gravity alone could not account for. Astronomers were baffled, but the announcement was kept quiet. No big announcements, no media attention, just data quietly exchanged between government agencies. Then 2019 came. Comet Borisov was discovered, the second interstellar object. Again, strange properties. Again, government movements that seemed uninterested but collected data in a peculiar way. And now in 2025, we have 3I Atlas, the third interstellar object, with exactly the same kind of anomalies we saw in the two objects before. This is not coincidence. If one interstellar object is anomalous, it could be chance. If two consecutive objects are anomalous, you start paying attention. But three objects in succession with the same kind of signs, the same kind of anomalies, the same kind of government silence, that is not coincidence. That is a pattern, a conscious pattern, with purpose. The question is, who or what is creating this pattern? Are these objects part of the same diplomatic mission? From the same civilization, the same exploration program, or are we simply noticing them now? And all interstellar objects have strange properties. We just didn't see it before. Now, a deeper secret. NASA has a public program called Planetary Defense. Official purpose: identify asteroid hazards, protect Earth from potential impacts. It is public. Everyone knows about it. There are annual reports, scientific conferences, press statements. But there is something not everyone knows. There is a higher level, classified, a secret program within planetary defense. Real purpose: not just track natural asteroids, but track anomalous interstellar objects, unexpected visitors from other stars. Oumuamua on the classified list. Comet Borisov on the list. 3I Atlas just added. Why keep it secret? If these objects are natural, there is no need to hide anything. But if they are artificial, if they are probes or tools sent from another civilization, if they could be military instruments or reconnaissance devices, then you would want to keep it secret. You would not want the public to know that strange objects from space are visiting our solar system. Pay attention to what doesn't happen, what is silent. China did not announce the Tianwen-1 mission to photograph 3I Atlas in advance. They only announced after it succeeded and said it was a technical test. They did not overflow with discovery. They did not request international cooperation. They simply announced the photos and withdrew. NASA did not ask China to release all raw data. Usually, when significant international discoveries are announced, there are discussions, requests to share data. But here, nothing. ESA did not organize an emergency international conference. No special announcements, no global meetings to discuss 3I Atlas's significance. If 3I Atlas were just an unusual comet, why this silence? Why no scientific excitement? Why no public debates? The only answer that makes sense is governments already knew. They saw preliminary data. They conducted their own analyses. They drew conclusions they decided not to share with the public. And they decided, keep it secret. In 1967, an important treaty was signed, the Outer Space Treaty. 110 countries signed, including the US, Soviet Union, now Russia, China, and most major nations. Main content: cannot develop weapons in space, cannot develop military technology to control or destroy space property. But the problem is, how is weapon defined? The treaty is not extremely clear. It can be interpreted many ways. Now, imagine major nations see 3I Atlas. They analyze it. They conclude it could be a potential threat from an extraterrestrial civilization or from a potential enemy. So they decide we need to develop defense technologies. Technology to protect ourselves from space attacks. Technology to intercept or destroy threatening objects. But wait, is that a weapon really? That is defense. Defense is not a weapon. Defense is protecting yourself. Protecting the planet. So under these explanations, governments can use 3I Atlas, a real object from space, clear evidence of a threat, to argue for developing interstellar defense technology, secret technology, military technology, technology never disclosed to the public. Now, the final information. Information from insiders. According to a source from an anonymous NASA employee, their name does not matter, but their credibility does. There is another discovery. ESA's Gaia satellite, one of our most precise telescopes, has detected another interstellar object approaching our solar system. It will arrive in 2027, just 2 years from now. Its characteristics? Similar to 3I Atlas. Same kind of anomalies. Same kind of motion. Same kind of strangeness. Same kind of pattern. This information is classified at the highest level, meaning only a handful of government employees know. It has not been publicly announced. The public does not know. The press does not know. Independent scientists do not know. But if a second consecutive object has the same kind of anomalies, same pattern, same signs, same characteristics, same kind of abnormality, then the probability they are part of the same larger project is very high. Not two independent events, not two random coincidences, but a convoy, a project, a plan. From where? From whom? For what purpose? We do not know. We can only speculate. But we know they are coming. We know they have been predicted. And we know our governments know. They just don't want us to know they know. So, here we are, November 2025. 3I Atlas still remains in the solar system, but not for much longer. January 2026, 3I Atlas will leave the solar system. Last observation chance. Then it will return to interstellar space, and we will never see it again. March 2026. Data from Tianwen-1 will be classified higher or removed from public archives. No clear evidence, but the fear that data will be cleaned is real. May 2026, NASA plans to release a space security report. Will it mention 3i Atlas? Will it disclose hidden findings? 2027. The next interstellar object will be detected. The pattern will repeat. But you don't have to just sit and wait. You can act. First, direct observation. If you have a telescope, you can see 3i Atlas. Until January 2026, it is still observable. Record brightness, position, time. Send data to Virtual Telescope Project or other citizen science portals. If your data doesn't match official predictions, report it. Create an independent observation network. Second, request data release. Write to your space agencies. Request full release of TN-Win-1 data. Release probability estimate reports for each anomaly. Protect data from classification or deletion. Third, independent analysis. If you are a scientist, if you have skills, recalculate. Reanalyze TN-Win-1 images using AI. Check official results. Release challenging findings publicly. Fourth, create public pressure. Social media. Campaign number 3i Atlas files. Ask your lawmakers to question government. Create independent journalist networks to track developments. Here is the truth. 3i Atlas is a test. It tests if we are ready to face the truth. Are we ready to demand transparency? Are we ready to form our own conclusions based on data? The world is about to change. Another interstellar object is coming. Opportunity to understand the truth is ending, but it is not over yet. Watch, ask, seek, reason. Because truth cannot be hidden forever. It just waits for enough people to seek it. 3i Atlas just gave us an opportunity to see, to understand, to decide for ourselves. Will we take it?